In this lecture, we will discuss about the Unit 3 moment distribution method in Structural Analysis 1 subject. In this unit, we have stiffness and carryover factors, the definitions, and the definition for distribution and carryover of moments. Then analysis of continuous beams, plain rigid frames, with and without sway, the effect of support settlement, then symmetric frames with symmetric and skew symmetric loadings. First, we will discuss some introduction about moment distribution method. This method is also called as displacement method because it involves displacement parameters, or equilibrium method because this involves equilibrium equations, or stiffness coefficient method because stiffness coefficients are used, or iterative method because we use the iterative procedure to solve the equations, or relaxation method because here we relax or distribute moments, or we relax the fixity of the joint. That's why it is also called as relaxation method. Or successive approximation method because in each and every step we will approximate. We will slowly reach the final solution. It was proposed by Hardy-Cross in 1940. Actually, it was based on the slope deflection method that we saw in the Unit 2. So, in this method, instead of solving of simultaneous equations of slope deflection method, we will do the iterative distribution procedure. It is less tedious when compared to strain energy method and slope deflection method. In this method also, we will only consider bending deformation. And this method can be used for all types of indeterminate beams and frames. But it is not applicable to space frame, indeterminate injointed trusses, and also trussed beams. It is also applicable for non-prismatic section. Then for very high degree of freedom, it is most suitable than slope deflection method. Now the principle of moment distribution method, it just begins assuming each joint is fixed initially. Then by unlocking or releasing and fixing each joint in succession, the internal moments, the joints are distributed and balanced until the joints have rotated to their final value. Just like a trial and error procedure. That is why iterative process. Okay. So the principle of moment distribution method can also be listed as steps. For example, number 1, first step is to lock the joint. That is, we have to fix all the joints irrespective of the nature of the joints. Then we have to release joints if that joint is actually simply supported. So while releasing the joints, we have to distribute the moments. That means we have to balance and distribute moment is the next step. So while balancing the moment, balance means we have to apply the moment and no opposite moment. So because of the application of moments, we have to carry over to the other end further. So carry over to further ends. If the further end is capable of carrying moments. So we have to repeat the steps third and fourth until we get the process stabilized, or the difference between successive iteration is less. Once the iteration is just enough, we can add up all the columns under each joint to get the final support moment. For sway analysis of portal frames, shear equations shall be applied. So next we will see the definition for some technical terms. Stiffness factor, represented as K, small k. Okay, it is defined as the moment required at the near end to cause a unit rotation at near end when far end is fixed. Since in this method only bending moment is considered, so bending stiffness K is equal to m divided by theta. That is acting force over the corresponding displacement. Now from this we can get m is equal to K into theta also. Okay, that is moment required to produce theta. Slope is equal to stiffness times that theta. Okay. So in the next video, we will discuss about how to get stiffness factors for beams with different end conditions.